Okay, let's quickly go to question 5. So on question 5, let's see what we have. Question 5. For this question, they say that the graph of g at x is equal to a to the x. They say it is drawn in the sketch below. So the point S, which is 2 and 9, lies on the graph. T is the y-intercept. So the first question, they want you to find what? Write down the coordinates of T. They never said, okay, it's fine. We can work this one out, but already we know what is the coordinates of T, guys. So remember, g at x is given as what? We have g at x, which is given as, let me quickly write this down. We have g at x. Maybe we can do this side. Okay, this is question 5. Okay, so question 5.1. Remember, g at x is given as a to the x, and they want us to find the value of, let's go back, the value of t. T is the y-intercept. So how do we find the y-intercept? We find the y-intercept if x is 0. Therefore, we can write this thing as y is equal to a to the x. Y is equal to a. Where there's x, we put 0. Any number to the power 0, it's 1. Therefore, the value of y is 1. We know that the coordinates of t will be what? We already have 0 as our, if x is 0, therefore the y is 1. That is the coordinates of a. That's how you collect that 2 marks. Then on 5.2, if we can check, where's that 5.2? They want us to find the value of a. To find the value of a, we just substitute the value of a as 1. We need to find the value of a. We can use this point to find the value of a, right? So now this is 5.2. Let's see what we have. We can say, we know that g at x is equal to a to the x. We need to find the value of a, and we can substitute the point what? We can substitute the point s. And s was given as what? S was given as 2:9. So this is your x, this is your y. So where there's y, you put 9, which is equal to, where there's a, where there's x, you put 2. Then we solve for x. Therefore, a is equal to, you square both sides. You square both sides, then you can say the square root of a, the square root of that. Therefore, a is plus or minus 3. We can conclude and say the value of a is what? The value of a is 3. Why? Because a is greater than 0. How do we see that a is greater than 0? If the value of a is greater than 0, your graph will look like this. So if the value of a is greater than 0, your graph will look like this. This is how your graph will look like. That's why we are saying that the value of a is greater than 0. I'm only interested in question, what is this? Okay, it's fine. 5.3 says that 5.3, these are easy marks. You just have to complete this question very fast. Question 3, they say that the graph of h is obtained by reflecting g in what? In the y-axis. Reflecting g in the y-axis. Remember, if you are reflecting about the y-axis, the x change. The sign of the x change. If you reflect about the y, the x-axis, the sign of the y change. So in this case, when they say about the y-axis, you just go on the equation, you change the sign of the x. Simple as ABC. It's fine. We can say this is 5.3. So on 5.3, we know that g at x, it's equal to what? G at x is equal to a. We have the value of a. So this will be 3 to the x. So now, to find the h at x, did they say h at x? H at x is obtained. So the graph of h will be what? So h at x is obtained when this reflect around the y-axis. You just change the sign and put it as negative. And this can also be written as 1 over 3 to the power x. It's fine. You can write it like that. But let me quickly explain why. Remember that if I have this, I can write this thing as what? As 1 over 3x. I can write it as positive, but it's fine. I can just put this thing as x and take out the common exponent and write this thing like that. Right, I know that some of the things you guys already know, so it's just a quick revision, but I'm only interested in 4.5. This one I'm not going to, and this is easy marks. For 5.4. 5.4, they say that write the values of x for which, okay, the values of x, what are we given? Let's quickly do this one. This is 5.4. So we need to find the log. We need to solve this. This is the log 3 to base x. Let me quickly check. The log 3 to base x is less than 1 and greater than 0. How can we solve this? Less than what? 1 and greater than 0. Guys, this is easy. 2 marks. I'm just going to show you how you can work this thing out. First thing first, focus on this number. You see this base. The number that you have there, your base, make sure that everything is to the power. You make everything, okay, let's say I have a to the power x. Right. If I have this thing, the whole of this thing, we call it this a power. Right. Then we're going to call a the base. Then we said x is the what? The x is your exponent. Right. So now make sure that you write everything to base 3. Write everything on that equation to base 3. You start with 0. Put it to base 3. I'm going to explain why. This must be less than 3. You take this whole thing. You say the log to base 3 x. It must be less than 3 to base 1. You just have to put everything to base 3. So the reason for us to do that, the reason why we are making everything to base 3 is because our aim is to do what? Our aim is to apply. I'm not sure. I remember someone said, I don't need the logs, but it's very important for you to understand the logarithm properties. The logarithm properties. Right. So this is where you're going to use the logarithm properties, where it says that if you have a to the log a to x, just know that this is just x. So for us to remove that, you see this, the log of 3 base. So basically this cancels. So then you are left with x. So this will cancel. Then you are left with what? We are left with 3 to the power 0 to be less than x, which is less than 3 to the power 1. So basically 3 to the power 0 is what? Any number to the power 0 is 1, greater than x, greater than 3. That is your solution. So x must be less than 3 and x must be greater than 1. Then you are done. You collected all the marks on question 5. Okay.